Hi, welcome to my art tutorials. My name is Dr. M. Karmakshaya. I'm an open source software evangelist. I have been explaining about how to perform data analysis using R programming language. In my previous video, I explained how to deal with bivariate and multivariate correlation. And in that video, I said that I'm going to explain as how to create a generic function to compute Carl Pearson correlation coefficients and the probability values, which means in short p values. I just only shown you how to compute the multivariate correlation matrix and also a matrix of p values, but every time we may not be able to do that. Each and every time we cannot perform all those strokes. Executing all those statements whenever we perform correlation analysis is not a reasonable idea. So it is better to have a generic function which can do all those activities within a stroke. So in this video I'm going to show you, I'm not exactly going to explain how to write the function for bivariate and multivariate correlation analysis. There are a few prerequisites. You need to know three very basic fundamental, both of them, three basic data structures. I don't call them types. The distinction between the data types and data structures is very narrow in few programming languages. In R, we just few authors call data types and few authors call data structures. Like whenever we talk of the data types, we refer the values. This is my previous suppose you have say string, okay, help as numeric. This is a function which is used to deal with all numerical values. All numeric values. So we have two functions, as numeric and is numeric. All the numeric values are managed with the help of these two functions. Like that, you also have as character. So character information is managed with the help of as character, is character, something like that. So here there is a documentation like as character, is character. Suppose if you have a, let's say x is some value. In R we use this. And now type of x, you see it is double. By default R treats everything as double. And suppose if you have x 2.5, and that is also going to be double. And then suppose if you have a value text, then you use type of x, then it is going to be character. Okay, there is nothing like integer, but you have a method called integer x. Then x is let me not do the experiments. 2 is integer, x false, is double, x true, as integer x yes. Now y is equal to as integer x. Now type of I have type of y, this is going to be integer. So like this, or x as integer 2, type of x, come on, now it is integer. So this way, these are all data types, but there are data structures. Suppose you have a tuple, a list, matrix, you got we call data matrix, data frame, array. These are all data structures. I am going to start my, till now whatever I'm talking is only the very fundamental core concepts of data types. Now I refer all of them as, like, say for example, tuples. There is no tuple in R. Okay, we just have to use the parentheses like this. We use a C operator, 1, 2. That's it, 1, 2. This is tuple. We have list. This is so I'm going to cover list. The first one is matrix, list, data, maybe matrix, data frame. These are some of the arrays. These are some of the very, very fundamental data structures in R. So let us know each one of them one by one. So the first one is going to be matrix. Let's come back here. I just type it here. So now first one is going to be matrix. So how can we understand matrix? A matrix is a very simple data structure. So let me use a separate script here because I already have script. Open new script. Let me open new script now. So if you don't know anything about matrix, then you can use help matrix. Now you'll get this documentation, read everything. You see this is the syntax. Whatever we put data here in as a first argument, that will be converted as matrix. But you have to take care of one important thing. You have to be very cautious about the number of rows. Every matrix has an order, so that order should be the multiples of rows and columns. So before designing the matrix, it needs a strategy to create a matrix. So that strategy is the multiples of the rows and columns. So now let me create, suppose if let me take multiples of 4 4s are 16. So I will create a vector of 1 to 16. This is just a vector, and once again this is a data structure in R. Vector, is vector, as vector, kind of vec. And there is another thing called factor. These are all alien data types which normally cannot be found in any other programming language. These are all R based. Now suppose if I want to convert this vector into a matrix with an order 4 by 4, then matrix 1 to 16, then rows, number of columns. Now there are a couple of other arguments. Now let us not talk too much. Let me not talk too much. This is a simple and sleek statement. When you press enter, then obviously that vector will be converted into, this is not the same vector. Suppose if you have a vector like this, vec, then 1 to 16, or for that matter anything. Now matrix, vec, 4 rows, 4 columns, and now you see these elements are filled as by row, right? You have an argument called by row. By row. If you say by default it is true. If you say false, now R will try to fill them by column. Now you say by row, true. You got the 1 2 3 4. This is by row true. This is by column. So you can either use this colon operator inside the matrix. You can also use this. You can also create some text. Suppose if I can make letters. Now I call letters, or let us go for the small letter, lowercase letters, 1 to 16. So you can, I'm just telling you how to create a matrix of my brain is going down now. Matrix, let's 4 by 4. Now you see you got the matrix of letters, something like that. So this matrix can accept anything, not only the numbers, it can also accept character based information. You can just make use of matrices to Now you see I'm going to convert this. I can imagine this as a data matrix. Okay, let's suppose, you know, there is a concept called data whenever we create this, we use this function matrix, that is going to be a data matrix. And a data matrix is a kind of let me create an object mat. So I already have this, I think, like, yeah, I call this mat, just a user created object, I mean user object, just don't worry, type of mat. Now I say sorry, I'm doing too many mistakes because it is an integer based, it's not a matrix. Okay, is matrix mat true, it's a matrix. Now is it a data, is data matrix? No, I think you don't have data matrix. Is it a data frame? You have is data frame mat? No, it is not. Come on, false. Okay, it's not a data frame, it is just a matrix. Okay, data matrix, yeah, you have data matrix. Data frame can be converted into data matrix, but not the matrix into data matrix. Now say this is a matrix, mat is a matrix. Let's see what is this is. Let's imagine that we have 4 columns and all of the columns are variables and these are going to be the rows. Now mat, I am going to show some, no, I don't need to show the, I will just convert this matrix into a data frame. Now let's see what's going to happen. Data frame mat. Why this is coming? Dirty. You don't know what is happening. Stupid. Yeah, you see now we got extra names for this matrix. Now the same data matrix is converted to a data frame. These are all, you know, the data structures in R. Okay. This way you can create the matrices and convert them into data frames. Now this data frame is a structured data matrix in which you have some valid columns, and each column can be, let's suppose you can find mean, and if you say my data frame, something like that. Now names of, it has valid names x1, x2, x3. Now you can go for mean my data frame and then x1. So you can do, but the same thing cannot be done yeah, mean 1, yeah, mean 1, it's not x1. You can do this, I think x1, yeah. So this way you can do any analysis on this data frame. So this is all about the data matrices. Because I didn't talk much about matrices, list, data matrix, I mean there is no data matrix, let me, only data frame. So now I told you how to create the matrix and convert that into a data frame. Now let me talk about the list. A list is the collection of different data structures. Suppose say for example you have a data matrix you call my I think mat you have, right, and I have my df. There are 2 different data structures. Now suppose I just wanted to combine these 2 data structures and make a unique data structure, then the only way is to use this type called list. Now I can just use list and then say mat and my df. Now this is going to create a simple one single data structure in which we have 2 different elements. In the first element is the matrix and second element is the data frame. Now if I my list, I think I already have this, right, my list, and then if I use my list and then I can just it is not my list, I have to use this notation. You see here the element 1 is referred as is a square brackets within the square brackets. Then if you press 1 then you have the matrix, if you press 2 then you have the data frame. So most of the time we'll be using this technique in whenever we write the functions, and this technique I am going to use while performing the multivariate correlation. We need this particular step. Now let me cover arrays. Arrays usually we don't use, I don't know why it has in our community. very rarely we use arrays. Most of the time we don't. The lists are really magical. There is a lot of magic in lists, but arrays I don't think they are much useful. But anyway, people who come from this C, Java, they prefer arrays, kind of, very old and ancient methods. Now, how to deal with arrays? Now, suppose if you are creating, let's say for example, you can't make an array of mat. Let's say you can also do this, but let's see what's going to happen. Mat and mydf, and you see here there's going to be a rubbish kind of. Now let's for example, because both of them is already a list, right? So you cannot use them like, but you can make one thing. You can do one thing. Suppose if you have suppose I want to create I have a vector in which I have 16 plus 16 32. So I am going to create a vector. I already have vector, right? So vec is so I am going to update vec with vec c vec, and then I think 17 to 32. Okay, so now let's see what do we have. So 1 to 16, 17, 32. So that is just, instead of just making 1 to 32, I can just make this. We don't need to struggle like this, 1 to 32, because I thought anyway I have vec, and now vec I have 1 to 32. Now let us make two different matrices. Suppose if you would like to divide this entire vector into two different matrices, one matrix with 1 to 16, the other matrix with 17 to 32, then we can use array. Array can be very much useful. Now here you have dim is equal to C 4 by 4 and two matrices. This is what is, you see here we got the two matrices. The first matrix is 1 by 4 by 4 order matrix, and the second one is 4 by 4 order matrix. You cannot have, the one potential disadvantage of arrays is that whenever we define dim with 4 by 4 2, these are all symmetric. They are not asymmetric. You can't have 4 by 5 here, you can't have 4 by 4. This is 4 by 4, you can't have 4 by 5 here, and your array is going to, because there is no method to make size, but list can do that. So that is why most of the time our programmers prefer list, not the arrays. I actually don't know why this particular array structure, maybe some kind of utility might be there, but I never encountered the usefulness of these arrays. Whenever I develop quite a few applications using RShiny. I never really come across this, the necessity for these arrays, and I don't think, okay, anyway, but list is very much useful. So most of the time whenever we write the functions, user defined functions, or write the advanced programs, we we use list, and they comes really very handy in a great way. Okay, so this way we can deal with matrices. In this session I explained how to write the matrices list, and how to convert the matrix into data frame, and also how to create the arrays. So this is for this session, and in my next session I'm going to show you how to write the function for multivariate correlation, and we are going to use this data structure list in that function. Thanks for watching this video.